and there will be some change of orders. So this semester is no difference, okay? But the contents we covered are, of course, are similar. And just sometimes we put emphasis on different places, okay? So if you have any questions, any comments, please don't hesitate to reach out to me. Okay, trigonometry review. Okay, so let me do a little survey. Just roughly, if you would respond, that'll be amazing. If you don't, you don't feel comfortable to, that's okay too. But I would appreciate if you could make the effort to respond somehow, either to everyone or just to me. Has every one of you taken a trigonometry before?
Yes, I have.
Yes.
How long ago?
Last year.
Last year. Okay, good. All right. So some people have not taken trigonometry before. All right. 2 years. Sarah, yes. All right. I certainly will welcome. Oh wow, we have more people who have not taken trigonometry before. Okay. Do we have more people? Yes, no. Wow, we have quite a few people who haven't taken trigonometry before. All right. So I will try to take care of everyone. Okay, but there's only so much I can do. So I'll get to the fundamentals and the essentials, okay, as trigger review. However, the fundamentals and essentials I can do for certain parts. There are certain parts such as the deriving identities, right, from proving from left to right, right to left. This part might be omitted, might be, might not be as emphasized as other things I cover on trigonometry. And for those of you who have taken trigonometry, that's certainly a good part that, once we get there, I will tell you, these are things you should continue to practice. For those of you who have not taken trigonometry, and you definitively should try those. And I may not have a lot of time to cover in class, so feel free to ask questions. I'll be happy to go over those with you. Because those skills are also very, very important. Your algebraic skills, okay? In trigonometry, there are lots of algebraic skills that require, which is reflected on deriving or proving identities. And those techniques, those skills will be much needed in calculus classes, okay? I hope to just let you guys know, okay? Especially those who have not taken trigonometry. You are in disadvantage. Okay. All right. So without further ado, everybody, okay. What are the most important things in trigonometry, if you can tell me? What are the most important things in trigonometry? If you have taken trigonometry, could you tell me what are the most important things in trigonometry?
Is one of them factoring?
Is it one of what?
Factoring.
Factoring. So you think factoring is important in trigonometry?
Well, one of them, yeah, for one of the points.
So that will be that's the technique wise, right? So it's an algebraic skill. Any other comments? Any other comments? Factoring definitively is a needed technique across the 5 courses, I would say 4 of the 5 courses, okay? Because you started learning factoring from elementary algebra, beginning algebra, intermediate algebra, college algebra, trigonometry. Okay, so factoring definitively is an important technique that will carry you through calculus. Okay, the most important concept in trigonometry, actually, there are three. Okay, I summarize them as A, R, D. Okay, A represent angles. A is for angles. Okay, any angle. R represent reference angle. D stands for definition. See, we have definition one more time. We have definition again. We have learned much definitions in the past, okay, especially from the beginning of semester, from function to one-to-one function, increasing function, decreasing function. And we talk about all these functions. We talk about all these functions from number 1 all the way up to the recent one we did. Let's see what number, which is a log, a common log, right? All those functions, there are 14 of them. Okay, primarily in basic 1 table, 14 functions. Each one has their own definition or rules. Okay, so the different rules, different descriptions. But trig functions, trig functions have their own specific description, which is a little bit more complicated than all of the rest, all of the above. Okay, so these three, A, R, D, I call them the 3 pillars of trigonometry. A, R, D, A, R, D. If you look at all the questions you're going to encounter in trigonometry, okay, there are 2 major types. One is from A to D. The other one is from D to A. All of the questions, okay, except proving identities. Okay, those questions is just it's a different category. Okay, that's require pure algebraic skill. If you master ARD, right? If you master ARD, the rest of the question you're going to encounter is either from A to D or D to A. And what is R? R is the bridge. R is the bridge. Okay, if you can master these 3, you'll be all set. So I'm going to show you and I'm going to teach you how to, how to apply these techniques and how to see the question as it is. Some of you may come to the class with a sheet of formula or maybe with a unit circle being marked. Those are all good, all fine. But what I hope is that after you have learned trigonometry, you wouldn't need any one of them. Okay, all you need is to master ARD. Okay, ARD. Those other things you bring to the class or bring to your study, they may be helpful for you, but never ever forget ARD. So now let's start with A. Okay, let's start with A. What is the trigonometry? How do we measure angles? For example, if you talk about functions, right? If you talk about functions, and we're going to be talking about these functions, 6 functions, right? Sine of A, cosine of A, tan of A, cotangent of A, cosecant of A, and secant of A. right? Some of you are familiar with it. If some of you may not be. All 6 functions, their input is angle. So our question is, how are these angles measured? Okay, so A is for angle measurement. How each angle, how each input is measured. That's about A, angle measurement. Okay, how are angles measured? Well, trigonometry basically is we take some triangles in geometry and we put them in a rectangular system. So it's a digitized geometry. Because when you do geometry, you don't need a rectangular system. But if you put a geometry in rectangular system, you are digitalizing geometry. Does that make sense to you guys? Why digitalize it? Because you will have specific position relatively. So each position, each angle, each point, they have their position precisely described by numbers, okay? Or you can say by ordered pair. So trigonometry is digitalized geometry, okay? That's my interpretation. Okay, so angle measurement. So these input, how are they measured? That's the question. Okay? Anybody want to contribute something to it? How are angles measured? The input angle are measured. Yeah, anybody has any comment? No comment. How are angle measured? You must know this. You must know this and be aware of it at all time. Okay? You must. All right. This red line, I call it the standard position. This is called standard position. Every angle is measured from the standard position. Okay, every angle is measured from the standard position. For example, I could start from the standard position. Okay, every angle is measured from the standard position. Okay, you may measure it from counterclockwise, and you have a terminal, and this line will be called the terminal of the angle. So the angle is measured counterclockwise. If this angle is measured counterclockwise, and we call it a positive angle. Okay. But what if I measure the angle from clockwise direction? If an angle is measured clockwise, and it will also have a terminal. The terminal all started from the origin, okay? So every terminal is started from the origin. In this case, the angle is measured clockwise, and the angle will be marked by a negative angle. You guys follow me? Yeah? Is this concept very important? How come we have forgotten about it? This is number one important thing in this class in trigonometry. Okay, A. Okay, so let's summarize it. Okay, if angles are measured from the standard position, if measured counterclockwise, it is a positive angle. Okay, if it is measured if an angle is measured clockwise, it is a negative angle. Okay. Got it, everybody? All right. The second concept, R, reference angle. Reference angle. What is reference angle? Every angle measured has a reference angle. In fact, it has a unique reference angle. Okay, so when we measure the angle, right? For example, if we measure the angle, we measure an angle starting from a center. I always start from the center position and the terminal. This is the terminal. Okay. The terminal of this angle A, okay, the terminal of this angle A, between the terminal and the x-axis, okay, there are two angles. There's one over here, and there's one over here. Do you see that? Okay. Now, what is the reference angle? The reference angle of an angle, say A, is the positive acute angle between the terminal and the x-axis. So I just draw, there's two angles here, right? Between the terminal and x-axis, there are two angles. So which one will qualify to be the reference angle? If you read the definition, it will be this one, right? So this one will be the reference angle. And this angle is acute. Has to be positive. Positive acute. So the key word here, not only the reference angle has to be positive, it also has to be acute. Okay, and this other one is not reference angle. You follow me? Now, let's look at some examples of reference angle. All right, I found a software online which give us pretty good pictures. The only thing I wished for is that I wish they have to give us radians, but it was not given as radians. So here, okay, I will send you the link. I'm going to send you the link. Okay. Wait. So you can play with it. Okay, so you're going to play with me. I'm going to send you the link, a copy, and go to Pronto. And here you go. Sent. So now you can play with the reference angle. Okay, so let's play this together. Okay. First of all, every angle is measured from standard position. See, this is the standard position. Okay, so I'm going to measure angles. I'm going to measure lots of angles. Okay, every angle is measured from standard position, and we are to identify. And this picture actually will give us the reference angle. Okay, I want you guys to observe. For example, if I measure the angle from the standard position and I get to here, 65 degrees. And what's the angle of 65 degrees? 65 degrees, right? Does everybody follow me? Because 65 degrees is the positive acute angle between the terminal and the x-axis. Now, if I do measure another angle, okay, I measure another angle. This time I'm going to measure, I will end up here. So the angle I measured is 425 degrees. What's the reference angle? What's the reference angle? It's still 65 degrees, right? Is it?
Yes.
So reference angles and the angle A, they're not necessarily the same, right? They're the same sometimes, they're not the same other times. But it is always the positive acute angle between the terminal and the x-axis. Okay, so let's do another one. Okay, so this time I'm going to measure a negative 295 degrees. And what's the reference angle for negative 295 degrees? 65 again. What have we seen here? What have we seen here? Each angle has a unique reference angle. But one reference angle could be a reference angle for many other angles, for many angles, right? You guys with me? Yes?
Yes.
So would you like to write it down? Your observation? Okay, so let's continue. Okay, then we can write it down a little later. You can start writing down now. Whatever you observe, you want to verbalize and summarize, okay? Now I measure another angle, which is 136 degrees. And And what's the reference angle for 136 degrees? It's the positive acute angle between the terminal and the x-axis. So the angle we measured is 136 degrees. And the reference angle is 44 degrees, right? If I measure another one, right? Negative 584 degrees, its reference angle is 44 degrees. So you can measure positive angle, you can measure negative angle. So for one reference angle, that reference angle could be for many, many angles, right? So if we keep going, you can see all these different cases, right? I can end up on the third terminal, third quadrant, right? This is 214 degrees. The reference angle is what? Is the positive acute angle between, I'm citing the definition of reference angle, it's the positive acute angle between the terminal and x-axis. Okay. I want you guys to be able to recite those words with understanding. Okay. So now let's speak the language. What is a reference angle? A reference angle is the positive acute angle between the terminal of an angle and x-axis. Okay, of course, provide that angle was measured all from standard position. So now, without further explanation, every angle we talk about is going to be measured from standard position. And we talk about the reference angle of those kind of angles. Okay, so one more. So suppose I measure from the standard position and I get a negative angle. What is the reference angle here? The angle measured is negative 53 degrees. And what's the reference angle? Positive 53 degrees, because reference angle always has to be positive and acute. We use the word and, refer to truth table. Refer to truth table. You guys follow me? Every and you mean is an and meant by truth table. Okay, one more. So if I measure from the standard position, okay, can I do this? (1040 degrees). What's the reference angle? What's the reference angle?
40.
Given to you. The positive acute angle between what? The terminal and x-axis. Okay, I hope that's clear. But now we're going to summarize. We're going to make some statement about what we saw. Okay, summarizing. Okay, so I'm going to make a statement here. Statement number one. Every angle, okay, measured from the standard position okay, we call it A. Every angle A measured from the standard position has a unique reference angle. Do you agree with me? It doesn't have two, right? It doesn't have two reference angle. It doesn't have zero reference angle. Every angle you measure, there's a reference angle, right? Right? Positive acute angle. Do you agree with this statement? Let's
Yeah.
examine this statement. It's unique. Okay, if you agree, write it down or write it down using your own words. You can replace the word unique or exactly one. Statement number 2. A reference angle could be the reference angle for many, as a matter of fact, infinite angles. Right, so if you see a reference angle, in your mind, how many angles could this reference angles be for? As many as you want. You follow me? Do you guys follow me?
Yes, Professor.
Yeah.
This is number 2
Yeah.
observation. So they're not a one-on-one. They're not a one-on-one. Okay? Reference angle is too many. If you have a reference angle, that corresponds to many. Infinite. Okay? But if you have just one angle, it only have exactly one reference angle. Does that make sense? Yeah?
Yes, Professor.
Yes.
You guys, we saw that, right? Any questions? Any questions? So this is the 2 pillars of trigonometry. Trigonometry, we must understand. We must understand. Okay? Reference angle and reference angle, they're not a one-on-one. Okay? Reference angle is one to many. One to many. Got it? All right. So we're going to do an exercise. We're going to do an exercise. Okay, you can use the picture we give you. You can use the link I send it to you. Okay, what I like to do, I'm going to create a situation. So you guys are going to give me an angle, okay, for the given reference angle. For the given reference angle, okay, so you're given 4 reference angles. 4 reference angles, 4 terminals. 4 terminals, okay? So this is a reference angle. And this is a reference angle. This is also a reference angle. This is a reference angle. And all of these reference angles, the reference angle I'm going to give you is a 70 degrees. Okay, your job, this exercise, you are going to give me one angle that terminates in each interval, but in each quadrant. Okay, can you do that for me?
Professor, you want to create breakout room also?
Yes, I will.
Thank you.
I'm going to write down the instruction. Give an angle that terminates in each quadrant with 70 degree as their reference angle. Is that clear? Is that instruction clear? Okay, so you're gonna give me an angle that ends on this line, on this reference angle. And you're gonna give me another angle that ends here, but has the same reference angle. Another reference angle that ends here. Another reference angle that ends here. Okay, you got 4. 1, 2, 3, 4. A, B, C, D. Okay, and I'm gonna set up a breakout room. You go there, by choice. Okay, and Farouz will be in that room and helping you to figure out. Remember, every angle has to be measured from the standard position. So your answer will be 4 angles that terminates in 1, 2, 3, 4 quadrants each, with reference angles equals to 70 degrees. Got it? Let's get started.
Thank you, Professor.
If you stay in this room, okay, you can use that the link I send it to you, okay? Just play with it. Just play with it. So your answer is going to be A, B, C, D. Your answer, each set of your answer has 4 answers. I'm going to give you 5 minutes. 5 minutes. Any questions from my group? People stayed? Not yet? Okay, I'm gonna grab something to eat, to drink. Okay, I'll be right back. How's it going? You know how to find it? The reference angle must be 70 degrees. Feel free to go around and round and round, right? To create positive angles, negative angles, right? There are many, many of them. You may find a pattern to create many. And if you like, you might want to try radians as well. You might want to try radians as well.
Professor, I came back. If anybody need my help, let me know. I go back to breakout room. Nobody.
Oh, nobody went?
No. So I draw the picture of it, and then I spent time to see if anybody shows up. So nobody showed up. I came back here.
Okay, it's okay. No problem, Farouz. I probably did get it. So I'm close. Oh, It looks like Jeremy went.
I go back to see.
Is Jeremy there? Is Jeremy still there?
I'm still here.
Oh. Are you in the breakout room?
No, that was accidental.
Oh, you came back. Oh, that was accident. Okay. So I'm just going to close it. Okay, thank you though. All right, so Farouz will come back. Okay. All right, so let's try this, right? Let's try a set of answers. Did you guys each find your own answers? You can put your answers on the chat, okay? I'm not going to be able to check everyone's answer. So you know what to do, right? Anybody want to contribute an example? I will take the first contribution.
For A, well, I think it's pretty simple. I got 70 because it's 70 degrees already.
That's right.
For B, I think I don't know if I got this correct. So what I did is I just simply added 70 to 1 and got simply added 7 to 70 and got 140. Then I subtracted 180 from 40 to get 40 degrees. So would that be the reference angle that equals for that answers the question?
So what do you get for second quadrant?
I got 40 degrees.
40 degrees. 40 degrees. Well, if you measure 40 degrees from the standard position, remember you measure from the standard position. So your 40 degrees is going to end up here, supposedly. That reference angle is not going to be, or it's not going to be 70 degrees. That's not going to work.
So it would be 140 then, right?
Well, how would you get it? How would you get that? You want to measure an angle that starts from the standard position, ends up here, right? Right?
Mm-hmm.
If this angle ends up here, the reference angle will be 70 degrees, right? And this angle will be 180 degree minus 70, right? You hear what I mean?
Yeah.
Okay. So 40 degree will not be a right answer. But you have many more. Okay. So I will use 180 minus 70. 110. Okay, so how about C in third quadrant?
Somebody respond on chat, Professor.
All right, someone has a comments on chat. All right. G-log. So he has 70 degree, 110, 250. So 250. 250 degree is 250 degree. Is 250 degree has a reference angle equals to 70 degrees. So let's check, right? Let's check. You can play with that link I sent it to you, right? So if you measure 250 degree, do you get a reference angle 70? Jivag, could you tell us how you get 250? I suspect he just take 180 plus 70, right? Is that how you get it? That's right. You see how he did it? He wants to terminate here. This is the terminal he wants to be. So how did he get there? That's 180 degree, and that's a 70. So that makes 250, right? You're gonna figure out your own way to do it because so far we only see positive angles. You can make negative angles, absolutely. Good job, Jubal. Okay, let's look at the fourth answer he got there. He gave us 290 degrees. Okay, so he gave us 290 degrees. Could you tell us how you get it?
60 minus 70.
What? Subtract 70 from 360. What do you think of that? Does that make sense, everybody? So he basically measured from the center to standard position, right? And here's 70. So what will be this guy? What will be his measurement? Is 360 minus 70, right? Do you guys see that? You don't have to use the same trick. You don't have to use some. You don't have to use the same trick. All right. So now we have one group of examples with our collective effort. Now, on 3 quadrants. Okay. Let me use quadrant 1, quadrant 2, quadrant 3. We're gonna do one more. We're gonna do one more. This time, the angle must be different from the first one, the first group. Do you follow me? And this time we're gonna try one more set. You're not gonna use 70 again. You're not gonna use 110 again. You cannot use 250 again. You have to use some different angles. Can you give me those different angles from terminating each quadrant with 70 degrees as a reference angle? Can you guys come up with those? Different from all of the above. Come on, guys.
Professor, I came with the general formula for that.
Yeah, we can have a general formula.
So if you create the breakout room one more time for maybe 2-3 minutes, if they're interested, they can join the breakout room.
All right, so write down the current answer. Your answer has to be different from the current one, okay? And Farouz has some secret to share with you. So breakout rooms, open all rooms, go for it. I'm gonna give you like 3 minutes, not too long. 3 minutes.
Thank you.
You can stay with me or you can go with Farouz. He got some secret to share with you. No? So you guys, hey, you guys, can we have a different angle other than 70 degrees that terminates in the first quadrant with a reference angle 70 degrees? Mitchell,
80 degrees.
80 degrees?
Yes.
80 degrees reference. Well, if you measure 80 degrees.
Oh, wait, no. That terminates in the first quadrant.
Right. The angle you select has to terminate in the first quadrant. Cannot be 70 degrees anymore because we use it.
It can't, yeah. Whatever angle terminates is the reference angle. So it would just be the same angle as whatever you choose.
And this is the only one?
For the first quadrant, yes. It can only be 70 degrees for a.
Are you sure? Are you sure?
Yes.
Think again.
Oh, never mind. 20 degrees? Wait. 90 degrees. No, I'm not sure.
How about 70 plus 360?
Oh, right. There it is.
Hmm?
Yeah, so 430 degrees.
Yeah. You go around, right? You come back.
Or 790 degrees.
That's right. You have this way, you have many, right? You can even have a negative, right? You can do plus minus 360, right? Yeah? Can you do plus minus 360? Of course, right? Does everybody follow me? But you only need one, so let's use plus. How about the second quadrant?
Or 520 degrees.
How did you get it?
540, sorry.
540, how did you get it?
I just added 360 onto 180.
Add 360 to 180. Or you mean 180 minus 70? That's a 110. I put it this way, I basically show you the method to get the angle. Right? Could anyone give me a negative angle? You guys need to think. You guys need to think about all the possibilities. How many angles can terminate on the second quadrant with the reference angle 70 degrees? You can certainly measure here, but we already have that angle, right? And then you can say, hey, I'm going to measure this way. Right? Can you measure this way too? Can you measure this way too? Do you know what I meant? Do you guys see that? Yeah? To end up here, measure from the standard position. I can measure this way, can I? Yeah? Yes? And I can measure like this, right? And one more, right? Do you guys get it? Can you come up with some different angles from 110, 111 degrees? This one is 111 degrees.
Negative 250.
All right, how'd you get it?
The 360, or sorry, 180 minus 360. Or sorry, no. 110 minus 360.
110 minus 360. Yeah, that will make it. Minus 360, right? What does that mean? 110 minus 360. What does that mean? I'm going to close that room, I think. Okay. So what does it, how do you get that? Right, you basically, you get to 110, right? That's a positive 110. And then you go around, that's a 360. Okay, so you end up with the same terminal. Remember, when you go clockwise, it's negative angle. When you go counterclockwise, that's a positive angle. You follow me? They're all measured from the same position. Do you follow me? This is about angle measurement and reference angle. All right, so this will be a good answer, but you have many answers, right? We have many answers. So this is going to be negative 250 degrees. Good job. Now, in the third quadrant, okay, welcome back, Farouz.
Thank you, Professor. Yes, we went through trial and error to see if we can get the general formula that was very interesting.
Yeah,
experiment.
sure, to play with it. Yeah, you can have a general formula if they're ready for it, okay? But some of you may be ready, some of you may not, but we're gonna touch back, we're gonna get to this again, you know, in other settings. And Orlando said 430 degrees. Is it for third quadrant? Orlando? Orlando? Okay, is this for third quadrant or which quadrant you refer to? Third or fourth? $430 degrees. How do you draw that 430 degrees? I did the first one. Okay. Well, that's okay. So we can figure out. Okay, you give a 430 degree, right? 400. So this is how I would figure out. 430 degree is equal to 360 plus what? Plus 70. So 430 degree actually end up in the first quadrant, right? So his answer is in the first quadrant. We already have that answer. We already have that answer. But it's good. We have an affirmation. We have affirmation. Okay. Now, if someone give me an angle that terminates in the third quadrant with a reference angle of 70 degrees.
510 degrees.
510 degrees. Could you tell us how you get it? You see 510?
You just add 360 on to 250.
Did you say 510?
Yes.
So you just add 250.
Oh, 610. 610, I'm sorry.
610. So he added 250 with 360. He got 610. Does everybody agree with it? That's good. It works.
That makes sense.
Let's go. Let's get to Farouz was just mentioned. He has a general formula for it. How about that? Isn't that amazing? Okay, how did your group do with that general formula, Farouz?
I guess we did very well. Basically, the reason I remember that general formula because Givor gave me the, remembering that general formula. The way he was calculating those 4 angles in the chat, if you look at it, write a plus minus 180 degrees. If you are given reference angle by simply using 180 degrees or 360 degrees, and we just refreshing our memory, helping each other.
That's right.
I cannot get the credit because I just learned it too a long time ago. Give or refresh my memory. So thank you for helping us to remember all these, tricks and techniques.
Yeah, of course. But this is their general formula for sure. We're going to get to that sooner or later. Since you guys are interested in that, maybe we just do a little bit more here, right? You can see one way to get another angle that terminates in the first quadrant with the same reference angle. You just add 70 degree with 360. Okay, and if you think in that direction, how about 70 degrees? Plus another 360. Huh? That's 2 times 360, right? Yes? So 2 times 360. How about 3 times 360? 4 times 360. How about minus? So you can be plus minus too. So how about we choose an integer, any integer? So this will be the general form, right? This will be one of the general forms. That this will guarantee your angle. You just pick a different k. If your k is 5, you go around 5 times, right? And you can do this for all of these. Okay, another one. Suppose you're already sitting at this reference angle. Okay, suppose you already measure an angle from here, right? That's the reference angle. And this angle, of course, is 70 degrees. If you add a 180 degree, you get another angle, right? So 70 plus 180, you end up on the other reference angle, right? So altogether, this angle is going to be 70 plus 180, 250. So this other angle will give you the reference angle of 70 degrees, even though it's not going to be in the same quadrant. It's on the diagonal quadrants on the other side. Do you guys see that? So you guys can think and play with these. This is essential. This is very, very important. So when we get to solve trig equations, this is one is most useful. Are you with me?
So Professor,
Yeah.
fine tuning that general formula, if we use an example, 70 degrees and the first one revolution, we get the next angle in the first quadrant. If we subtract, we still get in the first quadrant. Then when you mentioned, how about 180 degrees? So if we fine tune that general formula, instead of 360 degrees into 180 degrees, we can cover the other quadrants.
Well,
Also,
if you add 180, right?
replace it,
It's going to end up on the third quadrant.
right? I mean, replace the 360 degree with the 180 degrees, since k is the multiplier, and then k is the integer, right? Integer plus minus,
Right.
and therefore 70 plus 180, 70 plus 360 is 2 times 180. So that k representing integer can cover the other quadrants angle too. Is that something?
Right. Depending on how you do it. I want to make sure everybody understand what we're doing. So it's
Sure.
not this, it's just I and Farouz are talking and you guys are out of the conversation. I want to make sure everybody else is participating. Any questions?
Nope.
No? Okay. So one way is adding, multiples of 360. The other way is adding multiples of 180. But you have to think about the effect of doing that. For example, if you're sitting at 70, right? You measure this angle, the terminal is 70, you add 180. But if you add another 180, you're back. You add another 180, you're in the third quadrant. And you add another 180, you're back. So you can just keep going, but all of these will give you the same reference angle. And it is the same, it is true for the other ones. It is true for the other ones. Okay, but here I'm being specific. I want you to give the angles only in the first quadrant, second quadrant, third quadrant, or fourth quadrant. Do you follow me? So in this case, you need to add 360. However, on the third quadrant, okay, I think this might be a little bit tricky for some of you. Okay, so let's give it a try. On 360, on the third quadrant, could I use 70 degree plus 180 degree? And we can see that's going to be 250. But what if I multiply by 2 of them, 2 times 180? That's not going to work because that's going to go back to the first quadrant. You guys follow me? So you have to use odd number. You have to use odd number here. in order to guarantee is in the third quadrant. Do you guys follow me? You can use 1, you can use 3, you can use 5, you can use 7 to guarantee it is in the third quadrant. You follow me? Because you use even number multiples 180, you're going to be in the first quadrant. You follow me? But if you want to cover both first and third at the same time, yes, you just do 70 plus minus multiples of 180. You guys understand what I'm saying? I think you might be a little bit confused.
Very well said, Professor. Basically, it depends your question. If you have quiz question, you say find which quadrant, then
Right.
these are very important.
Right. You have to read the question very carefully. Okay. So let me just give you, since we are here, okay, I don't want you guys, I don't want to leave you guys puzzled without a clarifying, right? If as is right now, if it is as is right now, okay, I want you to give me the general formula for first quadrant, second quadrant, third quadrant. The general formula has to be just plus or minus the multiples of 360. Okay, so you can just use 110 plus minus k times 360. That will guarantee you're going back there. Okay, over here. So 250 degree plus or minus 360 here. And the fourth quadrant, right? We have a 290 there. And you can just do plus minus k times 360. K is an integer. Okay, so what we want to tell the reader, k is an integer. We talk about what integers are, right? Positive, negative, natural numbers or 0. Okay, now if I change a question, if my question is changed, okay, give all the angles. Okay, here I didn't ask you to give all the angles. I'm just asking you to give me one angle. You guys follow me? The question has to be, that's why I want to clarify the question. Okay, on these questions, initially I wrote it down, that was a clean. I just want you guys to give one angle terminates in each quadrant with the same reference angle, 70 degrees. Do you guys agree with me? That was the initial question. I had it here. You guys follow me? Yes, is everybody with me?
Yes.
Okay. Now, so if this is the question, this one is okay. This answer is, this is okay. This 1, 2, 3, 4, that's okay answer. The second one is okay as well. It's an or situation. Okay, you don't have to give both. Either one is fine. However, if I have a different question, second question, okay, I say instead of giving one angle that terminates in each quadrant with the same reference angle 70, and I'm asking you give all the angles all the angles that terminate in each quadrant with the same reference angle, then this will be the answer. You guys see the difference?
Yes, Professor, very well.
Okay, so you have to see what question is being asked. So now I'm going to give you, this is question number 1. Any question from you guys? Now question number 3. Give all the angles that terminates in quadrant 1 and 3 with the same reference angle 70 degrees. What would that answer be? That answer would be 70 degrees plus minus 180 degree. And the multiples is going to be 2k plus 1. Odd number. K is integer. Do you guys follow me? Now let's see what this means. What does this mean? What does this mean? Right? What does this mean? I'm going to give you 2 columns. Let's work some examples out. Let's work out some examples. 70 degrees K are integers. Okay? And what is 2k minus 1? 2k plus 1, sorry, 2k plus 1. If k is 0, k is 1, k is negative 1. Are you guys ready to play with me? Yeah?
That was a good example. Practice, practice, practice.
Practice, practice. Okay, this is actually a review, a little bit of beginning algebra about how to express odd number, even numbers. Okay, for example, if k equals 0, what is 2k plus 1? It's 2 times 0 plus 1 equals to 1, right? So what is that angle? That angle would be, this will be 1. So that's going to be 1 plus 180. That's 250. So this angle that is 70 degree, you add 180 degree, you end up here. You follow me? This is your 70 degree, and you add 180 degree, and that's 250. You guys with me? Now, if k equals to 2, what happens if 2k equals to 2? K equals to 2. I'm sorry, k equals to 1. 2 times 1 is what? It's 2. 2 plus 1 is 3. So now this time is going to be 70 degree plus, or plus or minus. We first do plus, okay? Plus. And 2k plus 1 is 3. So this is going to be 3 times 180. And what is 3 times 180? Okay, watch me. Okay, you do 70 degrees, 70 degrees, And then you do 3 180 degree, 180 degree, 280 degree, two 180 degree, another 180 degree. That's your angle. You see, this angle is measured from the standard position, and that will be 70 plus 3 times 180 degrees. Whatever that number is, that's what it means. So this other angle terminates what?
At third terminal, I mean third
At the
quadrant.
third quadrant,
Third quadrant, yes.
right? Then you say, how about the first quadrant, right? So the odd number cover all the third quadrant. How about the first quadrant? It's not covered, right? It's not covered. Then we need an even number too. Actually, I should change the question. I probably make it unnecessary. If all angles that terminates in quadrant 3, I'm sorry. I think I'll in quadrant 3. Okay, let's do this in quadrant 3. Sorry, quadrant 3. Okay, this will give you all the angles that terminate in quadrant 3 with 70 degrees. Okay, is that clear?
Yes.
Everybody else. My question has a little unnecessary typo there. Okay. Quadrant 3. We only want angles in quadrant 3. Now I'm going to add a quadrant 1 and 3. What are those angles? Question number 4. Question number 4. Quadrant 1 and 3. What would that be? And this time would be 70 degrees plus k times 180 degrees. So depend on the question. Right now, 1 and 3. And in this case, only on 3. Because you keep getting, you go from here and you always end up at the odd number multiples of 180. Okay, so now let's look at this number. I know this might be a little tough for you. Okay, it is a little tough. Okay, especially we're doing 5 classes in 1, right? So now let's do this again. So for our better understanding, okay? So k is an integer. K is an integer. Okay, I want you guys to play with some k's. Okay, k is 0, 1, -1, 2. You plug in the formula to see what you get. Everybody? Do you get those angles in quadrant 1 and quadrant 3? Do you want to go to the breakout rooms? Is everybody with me? We will need this sooner or later, okay? Very soon, very soon. Give all the angles that terminate in quadrant 1 and 3 with the same reference angle, 70 degrees. And the general formula is 70 degree plus k times 180 degrees. So now I want you guys to try these. Ruth, shall we do breakout rooms?
I'm ready for it because I believe in practice makes it perfect, but faster.
Yeah. So I'm going to add two more numbers, okay? I'm going to add two more rows. Okay, -2, 3. Okay, so you guys are going to plug in. I'm going to set up the breakout rooms. And you're going to practice with Farouz if you wish. And to see for yourself. If you're in this room, you plug in those numbers, and I want you to play with that link I sent it to you. Okay, but remember, it terminates in quadrant 1 and 3 with the same reference angle, 70 degrees. And we declare this is the general formula. And do you agree with it? But before you agree with it or not, you have to figure out, you have to know what this means. Right? You have to know what this means. Okay, so this table is just showing you what it means. For example, here you get a 70 degrees because 0 times 180 is 0. So you get this terminal, right? The next one you get 250 degrees, right? So that's over there. That's 70 plus 180. You ended up here. And the third one, we multiply by negative. So here, k equals -1. So this is -1. Oh, wait. All right, sorry. This should be -1. Okay, this is -1. So that's a 70 degrees. Before you do the subtraction, let me show you how to do it geometrically to measure that angle. So you end up with 70 minus 180 degrees. So what you do here, you measure 70. 70 is a positive, right? But they said 70 minus 180, so you get to 70 minus 180 is going to be clockwise. So you go back, you ended up here. That's your angle, 70 minus 180. Do you guys see that? So terminates in the third quadrant. So you're alternating between first and third, first and third, first and third, first and third. Do you guys see that? Yes? Now let's look at 2. So this time you have 70 degrees plus 2 times 180 degrees. Let's not rush to get the number, right? Let's not rush to get the number. Let's see how we measure that angle. We measure that angle by doing we get a 70, right? We get to 70 from the standard position, and then 180, another 180. That's the angle. So that's this angle here. Do you follow me? So you want to keep that form. You don't want to get the actual big number. You actually prefer this form because make the measurement so much easier. Right? Now, suppose you have -2. If this is -2, what you get? If this is -2 times 180, what do you get? Okay, so let me clean this up and do the other one. Okay, so now 70 plus -2 times 180. So this part means to be measured clockwise because it's a negative angle. Okay, so I have a 70. I get here, and then I have to go clockwise. 180, another 180. So I ended up here. So that's the angle right there. Last but not least, did you guys get it? last but not least, when k is 3, what do we get? It says you measure 70 and then 3 times 180, right? So 70, right? 180, 2 180, 3 180. So we end up here. And that terminal is 70 degree for reference angle. So 70 degree is the reference angle. Do you guys see that? So this general formula means that your k runs through all the integers, positive, -1, positive, -2, of course, also including 0, and so on and so forth. And that's the general form. That's the general form. Did I explain myself clearly? Okay, so let's wait for the other people to come back and you guys look at this to make sure you understand it. This is very, very important. Very, very important, especially you know, in a week or two, we're gonna get to use these knowledge. We're gonna use these knowledge. Okay. All right. Any questions? Reference angle, right? Once you have, we have angle, we have reference angle, and we have covered 2 pillars of the 3. And we have the 3rd pillar to cover. The 3rd one, the 3rd pillar to cover. Okay, which comes next. We may not get to it today. Well, we may get started today. But we're definitely gonna cover that tomorrow with the full force, Thank you, Farouz.
You're welcome.
Is there any questions, any mistakes made?
We get more, active, motivated, and thinking about the question. Definitely, this practice is gonna build up confidence, break out the ice between us and the math science.
Wonderful. That's great to hear. All right, you guys. Do you have any questions, please? These discussions, I promise you, is going to be beneficial for everyone. It's going to benefit me and also benefit my Farouz because we want to understand each other. Okay? You try to understand me. I also try to understand you so I can better serve you. Okay? All right. So without further ado, right? So these will be the typical questions. Okay? And now, question number 5. I want you guys to think about this. Question number 5. We have all the angles that terminate in quadrant 2 and quadrant 4 with the same reference angle, 70 degrees. Can you do that? How about we leave that as your homework? So could you please write them down? Write these questions down. Write this question down. Okay, so we can get started on D. We're going to get started on ARD D. Definition. Okay, so this question number 5 is your homework. Definition. The definitions for all the other functions we did from first one to number what? Number 14. Okay, they are all pretty straightforward. Okay, from the first one to number 8, they're all very straightforward. The rule is described very, very clearly, right? With a simple formula. And then number 9 through number 14, it has a little more complication, right? You have to make a connection between exponential and logarithm. And the definition for trig function is a little more complicated. It's a little more complicated. Okay, why? Because in order to make this definition, we have to set a stage. We have to set a stage. Okay, so first we're going to have a stage set. It's like a performance, right? You have to put the lights in place. You have to put the, whatever setting you need. You have a little house there. You have to have that house over there. And you have some, whatever you need for the performance. It's kind of stage set. That's why I call it, it's a stage set. You have to have some assumption made. You have to build a stage. And what is that stage? What is that? The stage set is not that complicated, but it's absolutely necessary. It's absolutely necessary. Okay. So what I do is I take a trigonometry textbook. I'm going to copy from that trigonometry textbook word for word. Okay. So here's the stage set. Okay, I'm going to type and you're going to copy. If A is an angle measured from standard position. Sometimes they also call it in standard position. In standard position means measured from the standard position. Okay. And the point x, y on the terminal side of A, other than the origin. This is the stage set. From these words, we're going to have to build a stage. And what is that stage? Right? I want you guys to think about what these words mean. We haven't finished. We haven't finished the definition. We're going to continue tomorrow. But I want you guys to think about what do these words mean? The if statement, what does it mean? And I told you, is this make a stage set? Right? It set a stage. So we're going to draw a picture to build that stage. Okay, we'll do that tomorrow. But before tomorrow, I want you guys to think about it. Okay, and if you like, you may like to, if you still have your trig textbook or you have a pre-calculus textbook, go to that trig definition part. Go to that trig definition part to study. And I will see you guys tomorrow.
Thank you, Professor.
Thank you, Professor.
Thank
See you
you.
guys tomorrow. Tomorrow we're going to build the stage.
Thank you.
Thank you.
Thank you. See you tomorrow.
Good job. Thank you for your participation. Really
Have a lovely
appreciate it.
rest of your day.
You too. Thank you. I'm looking forward to seeing you guys tomorrow.